Luigi Galvani, an Italian scientist, applied static electricity to the leg muscle removed from a dead frog and found that the muscle contracted. Alessandro Volta, also an Italian scientist, studied Galvani's work and began to suspect that some of Galvani's observations may have been caused by a chemical reaction involving the metals used to probe the frog leg. That led Volta to attempt to generate electricity using dissimilar metals immersed in salt water. Iron, copper, zinc, silver, tin, gold, lead, and perhaps nickel would have been available in his time. He determined that zinc and copper produced the best results. He discovered that he could increase the effect by connecting together a number of pairs of copper and zinc discs in a column that was called a voltaic pile. Each pair of discs included a saltwater-soaked cloth disc between the copper and zinc. Salt water reacts chemically with zinc, releasing electrons that flow to the copper. This was the first method of achieving a sustained flow of electric current. It was a very important milestone in the development of the electrical technology that is essential to the way we live today. Since U.S. pennies have been made of zinc coated with copper since 1982, they can be used to make a voltaic pile. It is necessary to grind or sand the copper off one side to expose the zinc. Cut circles of cloth the same size as the pennies. To start, put a small piece of aluminum foil on the table to have something to connect to the meter. Then put a regular penny on the foil. Put a circle of cloth dampened with salt water on top of the penny. The salt water needs about 4 tablespoons of table salt in a quart of water. Put a ground penny with the ground side down on top of the cloth. Then add another saltwater dampened cloth and another ground penny, and repeat until you have added all of the ground pennies that you have prepared. Carefully wipe off the outside edge of the pile of pennies. Salt water on the sides will make a short circuit and prevent voltage between the top and bottom of the pile. Press the pile together a bit when measuring the voltage. The meter shown was purchased at Harbor Freight for about $7. The meter shows the electric force or potential measured in volts in honor of Volta. The switch on the meter needs to be set to a voltage that is higher than the expected voltage, higher than 1 volt per penny. Another battery arrangement that Volta used was a series of cups, often arranged in a circle and called a crown of cups. Shown here is a crown of cups made with zinc-coated, hot-dipped galvanized nails and copper wire. The solid copper wire must be wrapped around the nails and tightly twisted to make a good connection. It should be possible to get 7 or 8 volts with 9 cups, fresh nails, and good connections. The green light-emitting diode, LED, makes the voltage drop to a little more than 2 volts. Lemons or potatoes can also be used to make batteries. Zinc-coated nails and copper wires can be pushed into the lemons or potatoes. Several lemons need to be connected like the crown of cups to produce very much voltage. You can also cut the lemons in half to make 2 cells per lemon. For a quick lemon battery demonstration, you can use aluminum foil and an ordinary penny. No need to grind off the copper. Put the penny and a piece of foil on a half lemon as shown. Thank you for watching. Please visit wiscimuseum.org.